All right, so we were doing R6, which was rational expressions. What? So math 35, R6. And we did some of this before. I want to start you off, and I think we might have even done this problem. But let's just take a look at it again. X squared minus 4. I'll just make it simple. Over x minus 2. Maybe we didn't do this one. So we want to identify where there's problems, like where x can't exist, and then we want to simplify. And I can identify where there's a problem right away because the bottom doesn't factor. So I do not want x minus 2 cannot equal 0. And if I plug in 2, 2 minus 2 equals 0, which means x equals 2 is bad. Bad juju. We don't want x to equal 2. If we factor the top, what do we get? Not from anybody that just did this 15 minutes ago in Math 335. How do we factor the top?
X plus 2.
I just got done saying anybody that was here 10 minutes ago, don't say. Yes, this is a squared minus b squared. This is x minus 2 and x plus 2 over x minus 2. We've made note of this, so now we know that x can't equal 2. We can cross these out, and the answer is just x plus 2. This becomes important a lot in calculus, and I'll tell you why, because you're eventually heading there. What we're going to do is x can't equal 2, but what we're going to do is go, what happens as we get close to 2? Like this is explored in calculus. And the way they describe what happens as we get close to, they call this doing a limit. And they say the limit as x goes close to 2. So they have an x with an arrow going towards 2. And they'll give you the full thing, x squared minus 4 over x minus 2. And you're supposed to figure out what happens. Now, as it goes to 2, it should work. The only problem is the number 2 itself. So 1.99 should work, 2.01 should work. And so does it like lead to the same value? If I come in from below 2 and do I come in from above 2, does it lead to the same value? When something like this and it cancels on top and bottom, it does. It's called a removable singularity. We'll look at this later. If it doesn't cancel out and we just have it left there on the bottom, it's going to have some weird graphs. But the way this will behave, it behaves like the limit as x approaches 2 of the simplified form. And when there's no problems, you just plug in the value. Plug in 2 plus 2 equals 4. So this is approaching 4 in value. So if I said y equals this, then y approaches 4 as x approaches 2. And I'll show you that. I'll give you a second to finish writing this down. I loaded it up on Desmos just to show you. Like, why are we doing it? This is why we're doing it. Because we can. So the line y equals x plus 2 is a straight line right here. And like the horizontal part is X values, the vertical part is Y values. So if we want to look at where X equals 2, we go along this line until we get to 2, which is right here. And we follow it up until we get to 4, which is right here. Notice if I put my cursor over the line and hold down the button, it gives me right here, it says 0.76 and 2.76. The first value is my X value and the second value is my Y value. So as I get closer to 2, that number is getting closer to 4, isn't it? It's really close to 4. 1.99, 3.99. As soon as I get to 2, it says undefined. In fact, over here, the dot is solid, if you can see it. There's a dot is solid, but as soon as I get to the undefined spot, it shifts into a hollow thing to say that the graph doesn't really exist there. And unfortunately, Desmos, it doesn't matter how much I zoom in, it's always going to look like it exists there. Until I do the hold down the button. So it doesn't matter how close I get, it still works. This is something you'll look at in calculus. And this is why we're looking at this. Because you don't want to have to graph this when we can do stuff like this and just figure out right away what's going on. Just plugging in 2 gives us the answer. That's handy. All right, so we've looked at, cleaning up these rational expressions. Just like fractions, we can multiply and divide rational expressions. We can multiply and divide. So we can do it with rational expressions too. As well. And since there's not a lot of room to work on this page, I'll just remind you how it works. If we have A over B times C over D, we get A times C on top, B times D on bottom. B can't equal 0, D can't equal 0. That's multiplication. And A and C and B and D can be anything. They don't have to be numbers. They can be rational expressions. They can be algebraic expressions that they become rational expressions when we plug them in to this. They can be algebraic expressions before that. As a reminder of how we divide fractions, if we start with A over B divided by C over D, we can rewrite that as A over B times D over C. So the division turns to multiplication and the fraction flips over. A flipped fraction is called the reciprocal. Okay, so just like we had B and D couldn't equal 0 here. On the multiplication, same with over here. It started that, but we flipped it over, and so now we have C down here also. We also don't want C to equal 0. Over on this side, C can equal 0, but this becomes really fucking dumb really quick when C equals 0. Because then there's the whole problem 0. But rational expressions still allow it. So let's look at applying this to, we'll start with the simple rational expression first. Let's do 6x or 6x to the 6th power divided by 7 times 28 over 9x squared. Ideally, you want to simplify the stuff as you're doing it rather than trying to wait till the end. I could multiply 6 by 28, but I don't, that's going to be giving a big number. And it's going to be kind of hard to factor. So the strategy I'm going to take about doing it is I will factor everything as I'm going. 6 is 2 times 3. And I can leave x to the 6 like that. And the bottom is 7. And I'm multiplying it by, I've got 9x squared on the bottom, which is 3 times 3x squared. And the top is 28, which is 7 times 4, which is 7 times 2 times 2. I cross stuff out that's on top and bottom, and you've got to go in a pair, one from each. The 7s go away, reducing to 1. I have a 3 that goes away on top and bottom, reducing to 1. There's not another 3 on top, so I can't get rid of the other 3 on bottom. And even though they both have 2's in both fractions, they're all on top. So if I multiply this over, I've got 2 times 2 times 2 is 8. X to the 6th on top. The bottom is 1 times 1 times 3 is 3 x squared. And we talked about how to deal with when we have exponents on top and bottom. That becomes 8 over 3 times x to the 6 minus 2. When we have exponents with on top and bottom for the same variable, we just subtract them, subtract the bottom from the top. So the simplified form of this is 8/3 x to the 4th power. All right, let's kick it up a notch. This is gonna take some work. For the top one, I'm gonna call this A and I'm gonna call this B. So that I can do a little bit of work over on the side. A. We need to do the factoring, so I'm gonna do the A times C is 4 times -10 is -40. And I need those to add up to +3, which is B. There's not a lot of things that have multiplied to 40 on the times table, but 8 and 5 are some of them. So if I do 8 and 5, if I make the 5 negative, I'll end up with +3. And this will give me a way to split up this 4 or that 3n. I'll have 4n squared plus 8n minus 5n minus 10. And I can do some more grouping. I got 4n times n plus 2 minus 5 times n plus 2. And then if I factor B, A times C is -4, B is 3. Looks like +4 and -1 will work. So I have 2n squared plus 4n minus 1n minus 2. And if I finish factoring that, I get 2n minus 1 times n plus 2. There's nothing to factor in the second fraction, but there will be on the test. You'll have to factor all 4 quadrants here, all 4 things. Let's just rewrite what I have though. A, if I finish up A, I've got 4n minus 5 and n plus 2, and that's going to go on top. And on bottom, I have 2n minus 1 and n plus 2. And I still have the 2n minus 1 and n plus 4 over there. Okay, so we want to identify where the denominator can't equal 0. That's still important. And I should have done that up here, and I didn't. That's what we call a slacker. If I plug in, if I deal with the 2n minus 1 and I don't want it to equal 0, basic steps in algebra, and we'll cover this in more detail with more examples in chapter 1, but you want to get n by itself, so you undo every operation that's happened to it so far. Right now it's subtracting 1, so the opposite of subtracting 1 is adding 1. So if I do that, I get 2n does not equal 1. And right now n is multiplied by 2. If I want to undo multiplication, division undoes multiplication. So I can divide both sides by 2. And if I do, the 2's cancel and I get n cannot equal 1/2. The other ones you can do by inspection. If I want this to not equal 0, I should just use the opposite of this number right here. So -2 is the opposite of 2. We don't want -2. And -4 would cancel out a +4 and make it 0 also. So we don't want -4 also. Those are some restrictions called domain restrictions. And now we can start cleaning shit up. The 4n minus 5 does not cancel out. The n plus 2's do though, as does the 2n minus 1. In both cases, leaving 1's behind. The only thing left on bottom multiplied by those 1's is that n plus 4. So the simplified rational expression is 4n minus 5 over n plus 4. You guys ready to pick it up a notch? All we're really doing is we're just factoring more stuff. We've factored, just like the last chapter, last few sections we've been doing, is just factoring. So you're getting a lot of practice with factoring. But let's just go big. I'm going to have 5z squared minus 16z plus 3 divided by z squared plus z minus 12. And then I'm going to say divided by another fraction, 30z squared minus 6z over 2z cubed plus 8z squared. So you have two options. We're going to have to do both of these options. It's just which order you want to go in, and you got to make sure you do both orders. We're got to factor everything, and then we got to deal with that division by flipping the second fraction over and making it multiplication. So I kind of like flipping it over first. But the problem is then you might forget what you don't want equal to 0. But in this case, we don't want anything on the right side to equal 0. So we could flip it over first, and that's what I'm going to do. And I'm going to bring down the rest of the problem. And I'm going to change that to multiplication. And this is going to flip over 30z squared minus 6z on bottom, 2z, that has the wrong thing. I want 2z cubed plus 8z squared. And I'll give you a few minutes to practice factoring it. Don't forget to look for greatest common factors. In fact, I'm gonna write up what the answers are, so that way you'll know if you got it right. So if you factor these, you should get this. And I made a note of what can't equal 0. I also don't want this right side, this top up here to equal 0. But the 2z squared falls under z equaling 0. And z plus 4 has already been done, so I didn't rewrite that. To this point, I can cancel out shit that appears on top and bottom. And if I do that, you'll notice we have just canceling out parentheses, all of the parentheses cancel out. And I have 2z squared over 6z, which is 2 times z over 2 times 3 times z, which ends up being z over 3. Or 1/3 z. You can write it like that too. They might give you something like this. So it doesn't necessarily have to be a trinomial. It could be 2 terms, it could be 4 terms. And when we did things with like that, we did them in pairs. So I'll factor in pairs. And if on the top one, I can pull out a y and I'll be left with x minus 2. And on the top, if I pull out a 3, I'll be left with x minus 2 also. Which means that top is going to factor into y plus 3 times x minus 2. And then if I do the bottom, the xy and 3x, they both have an x in common, and I'm left with y plus 3. And the y plus 3 doesn't have anything in common, so I'm just going to put plus 1. Which means I can factor this one as x plus 1 and y plus 3. So I don't want x to equal -1. I don't want y to equal -3. And if I clean these up, the y plus 3's cancel, and I'm just left with x minus 2 over x plus 1. You guys ready for more? Nope, I see pins still going. Let me wait a little bit longer. I bet your mask is bigger, almost as big as your head. I really do. She's straight up looks like a ninja. I'm waiting for her to pull out like a katana or some shit like that. Threaten me after class if you don't give me an A, I know where you live. I can hunt you down. I'm a ninja. I'll fuck you up, Mr. Jones. And you just got done telling me you work till 7. I can wait outside in the dark with my sword. Doesn't it look like a ninja mask? Oh, like full, almost like Master Shredder. It's not metal. All right, so that's multiplying and dividing. We can also add and subtract rational expressions. And the way we do this generally is if we have a over b plus or minus c over d. One way of doing it is just taking the denominator of one and multiplying it by the other. Doing it on both things. So this becomes AD over BD plus or minus BC over BD. And now that I have a common denominator, I can put these two together. And make it like that. That's like a general form without any numbers or anything going on. We will obviously want to simplify. And I think this form of multiplying by the other one isn't always the best idea, but it does always work. There are cleaner ways to do this. So let's look at an example. We're going to look at 3 over 10x to the fourth, and I'm going to subtract 2 over 15x squared. So I know if I want to get a common denominator, I'm going to need to multiply this one by something. And I'm going to need to multiply this one by something. And I don't know what it is yet. So rather than just using the 10x to the fourth and the 15x squared like you learn with regular fractions, what I'm going to do is I'm going to factor both of those. I'm going to factor 10x to the fourth. And I'm going to factor 15x squared. And I'll start with just the numbers. 10 is 2 times 5. And 15 is 3 times 5. I think I did this table with you guys before. We want to line up the numbers that are the same. So I'm going to line up the 5s. Next thing I'm going to do is going to look at the exponent that has the smallest number. X squared is the smallest number, so I'm going to just write this as times x squared. This will have an x squared also. And then whatever's left over is I subtract 4 minus whatever I just pulled out. So this had an x squared, I'm going to have x squared, and then I'm going to do x to the 4 minus 2, which happens to be x squared as well, but I wanted to show where I was getting it from. So my least common denominator will be 1 from each column. Which looks like 30x to the fourth. When I am done, I will have 30x to the fourth. Now, what I'm going to do is I'm going to look along each row and go, what is missing? Where are my holes? If I look at the 10x to the fourth, I'm trying to figure out what I want to multiply this by. The only thing that stops this from being this is that right there. It's missing this 3. So I'm going to give it to it. I'm going to multiply it by 3 on bottom, which means I'll multiply it by 3 on top. If I want the 15x squared to look like 30x to the fourth, it's missing this spot right here, which is a 2, and it's missing that spot right there, which is an x squared. So I'm going to multiply this one on bottom by 2x squared, and to make sure that I don't change the value, I'll do that on top as well. And I have 3 times 3 for the left one on top. My plus comes down, And I have 2 times 2x squared. And if I clean that up, I have 9 plus 4x squared over 30x to the 4th. Why don't I give you guys one to try? Four over 21y cubed plus 5 over 28y to the 5th. Getting 84 y to the fifth for the bottom. Did you guys get that? Just to make sure everybody's on the same page, I'll pause and let you guys continue working if you're still working on it. Okay, so if we look at the holes. The 21 is missing this 4. I could have put 4 was 2 times 2. But I was on the last thing and the other one didn't have any 2's to cancel, so why bother? And it's missing this y squared. So I'm going to multiply this by 4y squared over 4y squared. And this one, the second one is just missing the 3. So I'll multiply it by 3 over 3. And I'll get 4 times 4y squared plus 5 times 3. If I clean that up, I get 16y squared plus 15 over 84y to the fifth power. You guys get that? Or anyone to finish? Okay, good. Sometimes they're tricky. So what can I change here? If anything. I can't factor either one, can I? Yeah,
I would say what I did with the M-2, I would like to turn it into like. You can set the parentheses like 2 negative M and outside you put negative.
we could do that. We can switch the order. I'd rather switch the order on this one just because I like, but let's do what you said. You said change this one, right?
Yeah.
So one way of changing it is factoring out the -1, like he was saying. The other is if they're just in the wrong order or they have the wrong signs, I can multiply the top and bottom by -1. And if I do, this becomes -m plus 2, which means I can change the order around and make it 2 minus m. I'm going to have -7 plus 5m over 2 minus m, which would give me 5m minus 7 over 2 minus m. If you had decided to move the other one, or deal with the other one, and multiply this one by -1, we would end up with 7 minus 5m over m minus 2. And these two are equivalent. If you just multiply one of them by -1 over -1, you will get the other one. You guys ready for more? So this is already in a factored form, and I can do something similar with the table. It's just going to look a little weird. But if I write the table, and I start making columns of factors, x plus 2 is a factor, x minus 5 is a factor for the top one. I have x minus 5 for the bottom one, and then I have x minus 1. So the LCD will be x plus 2 times x minus 5 times x minus 1. This one already came in a factored form, which is handy. Process remains the same. The one on the left is missing x minus 1. So I'm going to multiply it by x minus 1 on top and bottom. The one on the right is missing x plus 2. So I will multiply it on top and bottom by x plus 2. We don't want to leave it like that. We want to clean it up to see if anything cancels. Because when we have stuff like this, stuff might cancel if we clean it up. And cleanup really only has to do with making the top get condensed and seeing if anything factors there. So if I distribute, I have 2 times x and then 2 times -1, and I have 3 times x and 3 times 2. And it doesn't look like anything cleans up. If I add the like terms, I have 5x plus 4, which does not simplify. And then I have this bottom right here. So the final answer will be 5x plus 4. The computer may or may not want you to multiply out the bottom. I can't believe I forgot my phone. It's twitching. Didn't get the shakes. Right? You just get so used to just checking your messages and shit. Even if there's nothing there, the fact that I can't check it is what's fucking bothering me.
Watch, I always keep checking my watch, see if I got anything.
Right?
Not even checking the time, I always get asked, "Check the time, you going somewhere?"
You got your phone linked to your watch. Yeah. It's being able to check it. Now it's like Schrodinger's cat. There might be a message or there might not be a message. But until I can open my cell phone and look, you will not know. I don't get a lot of messages. Pretty much my wife contacts me. I got friends that will message each other on like Messenger or on Facebook or something like that. And I can do that here. But all right. One more thing in this section, and then we will do some I don't know if it's R7 or R8, or it's just going to be a conglomeration of it all. Complex fractions is the nasty. 1 over y plus 1 minus 1 over y minus 1 over 1 over y plus 1 over y plus 1. I got fractions within fractions. That's what complex fractions means. Fractions inside other fractions. It's like fraction and section, if you've seen the movie Inception. That's an old movie. I need to stop referencing that. It's getting a little too fucking old. When did Inception come out? Yeah, most of my students weren't old enough to fucking go to the movies yet. 2010. It's fucking rough.
So.
Thanks. Appreciate that. That quickly, just you had a good grade and just fucking tanked. All right. So what we do, the easiest way to go about when you got fractions inside fractions, find the LCD or the least common denominator of all the inner fractions. And then multiply top and bottom of the big fraction by it. the outer fraction or big fraction. So. My inner fractions here are, I've got 1 over y plus 1. I've got 2 of those. I got one here and one here. I've got a 1 over y minus 1. And I've got a 1 over y. So my denominator, they all look kind of like unique. So I can just use each term. And I multiply that big one by that. Which means I gotta distribute it to each one. It's gotta go to that one, it's gotta go to that one. It's gotta go to that one, it's gotta go to that one. I'm not gonna clean anything up yet, I'm just gonna do that distributing. I've got y times y minus 1 times y plus 1 over y plus 1. That's my upper left one. My upper right one is y minus 1, y plus 1 over y minus 1. My bottom is y minus 1, bottom left, y plus 1 over y. And my bottom right one, I've got a plus, I've got y minus 1, y plus 1 over y plus 1. So that's taking that and distributing. Once you have that done, you can start canceling out shit on the top and bottom in the inner fractions. The way we did it, every denominator should disappear in the inner fractions, the small fractions. So in the upper left one, the y plus 1's cancel. And I'm just left with y times y minus 1. Then I have a minus sign. If I do that in the next group, the y minus 1's cancel, and I'm left with the y times y plus 1. If I do this here, the y's cancel, and I'm left with y minus 1 times y plus 1. And finally, I'm left with a plus and then y times y minus 1. At this point, we want to multiply shit out, see what we got. So I've got y times y up here, y squared minus y. And then I have, if I do negative y times y, I have minus y squared, and then minus y. The lower left is the difference of squares, that's y squared minus 1. In the lower right is plus y squared minus y. So on the top, the y squareds go away, right? Y squared minus y squared is just 0. And I'm left with negative y minus y is negative 2y. On the bottom, I have, if I gather my like terms of my y squares, I got 2y squared minus y minus 1. And it doesn't look like anything cancels because not every term on the bottom has a y and not every term has a 2 in it. So that's going to be my final answer. Any questions? All right, let's take like a 3-minute break. Let's stretch your legs or something like that. We're going to start a new section next. Hit stop record.